Welcome back, everybody. Continuing with part 4 of 3.1. So natural, logarithmic, and exponential functions. So the derivative of the natural logarithmic function, recall pretty much that from before we learned that the derivative of the natural log of x is just 1 over x, right? And then the chain rule version, so the derivative of the natural log of u is going to be equal to 1 over the function itself u times the derivative of u times over dx, which is just pretty much u prime over u. So that simplifies it a little bit better for all of us, right? So recall some of the following properties from Algebra 2 will be useful in calculus when dealing with natural logarithms. So pretty much, again, if a and b are positive numbers and n is irrational, then the following properties are true. Well, the first one, of course, the natural log of 1 is equal to 0, right? If the natural log of ab is equal to a times b is going to be equal to the natural log of a times the natural log of b. That's again the product property, right? If you guys recall that one. And then number 3, the natural log of a raised to the n is equal to the natural log, n times the natural log of a, right? That's the power rule for that one. And then the natural log of a over b, that's the quotient rule, will be equal to the natural log of a minus the natural log of b. All right, and remember the natural log is just log base e, right? That's what we call ln. That's why we have this one, because remember from previous courses, the logarithm is just the value of an exponent, right? So here, if you're looking at log base e of 1 is equal to 0, so this raised to the 0 power is equal to positive 1. And we all know that's true, right? Okay, so let's do some calculus now. So find the derivative of each, right? So again, the derivative is just going to be u prime over u. So I just need to find those two things, right? So u, which is the interior part, is just 2x. U prime is going to be just positive 2. So this is going to be 2 over 2x. And pretty much that divides out. So my answer is just 1 over x, right? So y prime is equal to 1 over x. And pretty much any function that has the natural log of b times x is always going to be just equal to, right? The derivative of that will be just equal to 1 over x, all right? As long as b is any positive integer or any positive number, as a matter of fact. Okay? All right, so let's look at b. B is a little bit different, right? We don't have that just bx inside. So now we have, it's still going to be the same thing. It's still u prime over u, right? So u here is x squared plus 1. I take the derivative of that using the power rule. That gets 2x. So this is going to be just 2x over x squared plus 1. And that's pretty much my y prime. All right. Okay. Now looking at c, we start to get things a little bit more complicated. Right now, be careful again. Be mindful of the things that you guys are doing, right? So try to read it aloud. I have x times the natural log of sine of x, all right? So I have a product here, so I have to be careful too. So that means I have to pretty much use the fish, right? Pretty much. So just to make it a little bit easier, again, x, derivative of that is 1. And then the natural log of sine of x, right? And the derivative of that, again, is going to be u prime over u. So that's what I need to find to get down here, right? U prime over u. So the derivative of sine is cosine of x, and then u is just sine of x. All right. So that's pretty much what it is. Draw your fish, right? And then from here, we can say that y prime equals x times cosine of x over sine of x. Quickest way to write this is just cotangent. Remember, that's cotangent of x, right? Sine over cosine is tangent. Cosine over sine is cotangent. So times cotangent of x, and then plus 1 times the natural log of sine of x. And that's pretty much it. That's our y prime. So again, don't be afraid of breaking it down into smaller steps, right? Okay, so let's look at D now. So on D, it's already, we have something raised to the third power, right? So the natural log of x raised to the third power. So here again, in this case, I have to apply the chain rule. So the derivative of the outside, right? So that would be, if you cover this up again, n is 3, and then your exponent is 2. And then the inside remains intact. So that's just ln of x. And then times the derivative of the natural log of x, which is just 1 over x. So this is going to be equal to 3 times the natural log of x squared over x. All right, and let's look at one more down here. So we're looking at y equals the natural log of x times x squared plus 1 to the second power raised to the, divided by the square root of 2x cubed minus 1. So again, you want to rewrite this as simple as possible, right? So this is the natural log of x times x squared plus 1 to the second power. There's nothing I can simplify there. And then here I have a square root, so it's going to be 2x to the third power minus 1 raised to the 1/2. So there's a couple of things you guys have to be mindful about here, right? So first, your exterior layer, right? The derivative of the exterior layer is just going to be u prime over u, all right? And then here, right? Pretty much one of the things that I would want to do is, before I try to attack this, right? I know some of you guys are mindful and are thinking, well, I want to apply the quotient rule because I see a quotient, right? So to make this a lot simpler, right? To make this a lot simpler, what we have to do is actually, I'm not going to apply this yet, right? I was actually getting ahead of myself, but I'm going to apply one of the properties of logarithms. That if I have a fraction, I can split it up into a subtraction, right? Right there. That's one of the nice things about logarithms. So this may look complicated, right? But I can simplify it by splitting it up. So I'm going to say the natural log of x times x squared plus 1 quantity squared, and then minus the natural log of 2x cubed minus 1 raised to the 1/2. All right. And I haven't even done a lot of calculus yet, right? I'm still doing algebra. So I can do one more thing. I have a product right here. So I can split those two up, right? I can split this and that. And then this is going to be the natural log of x plus, right? The natural log of x squared plus 1 squared minus, now this exponent right here, you can move it to the front. So it's going to be 1/2 times the natural log of x cubed, 2x cubed minus 1. And then that raised to the third power. Let me make sure I fix this. All right. Okay. And then from there, let's see what we can clean up still. You see, notice the 2 is right there. If you have an exponent, you can apply the power rule one more time. So it's going to be 2 times the natural log of x squared plus 1. And then the natural log of x. All right. And then everything else stays the same. That exponent on the inside, you cannot get rid of it because you have a minus 1 in there. Or because it just belongs to the x, right? So you got to be careful for that one. So at that, everything else stays the same. All right. So here, we're going to now start taking the derivatives because now it becomes more like a sum and difference rule, right? So y prime equals the derivative of the natural log of x is just 1 over x plus constant is 2. So this is 2 times u prime over u. From this one, that's going to be x squared plus 1 at the bottom. The derivative of that is just 2x. So times 2x over x squared plus 1 minus 1/2, right? And then again, the derivative of this one, you have u prime over u. So that's going to be 2x cubed minus 1 at the bottom. Take the derivative of that, you get 6x squared. So times 6x squared over 2x cubed minus 1. All right. And then from there, we have 1 over x. Try to clean it up a little bit more. Plus 2 times 2 is 4x over x squared plus 1. Minus, so 2 goes into 6 3 times. So that gives you 3x squared on top over 2x cubed minus 1. And that's pretty much my y prime. So again, if you guys see derivatives involving logs or natural logs, make sure you check to see if you can apply some of the properties of logarithms before trying to find anything else, right?